And welcome everybody to the Daily Space Weather. Congratulations on realizing our channel exists, and we thank you from the bottom of our hearts for tuning in to the content. First thing we're looking at here is the closest star. For all you stargazers out there, here's one. It's called the Sun, otherwise known as El Sol or perhaps Helios. We've got a major sunspot group up here known as 2895. It's capable of producing major flares, like M-class flares. We've got some prominences in the northwest and a lot more to cover. So let's blast through it. Here's the colorized magnetogram. These umbrae have been spreading apart, which is something that tends to happen before major solar flares and plasma filament collapses. Here's ionized helium from the SDO. All the imagery we've shown you today so far is from the SDO. We've got lots more to talk about. Indeed, including some amazing filaments in the northwest. Here's the entire northern hemisphere in this same wavelength, and we'll show you just the northwestern limb here. There you go. A great Earth scale there to give you the size, comparatively speaking, of these massive filaments. For you new viewers, keep in mind the Earth is not located there. It's 93 million miles away. The radio flux? I'm not sure what it is, but here's a 1-year chart of it. Yeah, the upper chromosphere and lower corona, they emit radio frequency photons. And there's the 1-year chart of that. It looks like we're back up to 88, I think is where we actually are. By the way, if you want to follow the KP index and so on in another location, check out the Potsdam KP index. If you type in Potsdam KP index in your favorite search engine like DuckDuckGo, if you scroll down and you click on the Nowcast KP index, you'll find this page. And that's another source, if you like, to look at stuff like geomagnetism and other solar data. Here's the Space Weather Enthusiast dashboard. Again, yeah, radio flux, 88 solar flux units. A solar flux unit, by the way, is 10,000 joules. That's radio flux density. And no geomagnetic storms or unrest forecasted by NOAA here in the next 3 days. Next, we're going to take a brief look at global seismicity. Yeah, earthquakes. And we're having a lull of 7 magnitude earthquakes here. If you look at the red bars, those are 7 magnitude earthquakes. You see that big gap? That's a statistical lull in 7 magnitude earthquakes. The largest of the past 24 was this 6.2 west of Lake Nicaragua there, out in the shallow portion of the Pacific Ocean, to the west of Central America. Let's consult the list to see what else has been happening. That one came in pretty early, by the way. And Smash Team members got an alert. At least silver and gold members did at smashomash.com/smashteam. So first we'll start out by talking about a deep quake at the Fiji Islands. It was a 4.5 magnitude at over 340 kilometers estimated depth. Another quake near Japan comes in at nearly 500 kilometers depth and a 4.1 magnitude. That would be like a magnitude 6 if it happened at the surface. So a bunch of deep quakes here, including this Puerto Rican quake, a 3.7 there in the Caribbean. And just continuing up the list here, what else do we have? Also, it looks like a 5.8 was one of the largest of the past 24. That occurred near Nicaragua as well. That's an aftershock of that 6.2. Here's another deep quake at a 3.3 magnitude in the shallow Aleutian Islands. Oh, it was a foreshock. I apologize. That 5.8 was a foreshock, folks. Now, let's hope that the 6.2 isn't a foreshock to a larger event. Again, there is a 7+ magnitude earthquake drought going on at the moment. And next we'll look at volcanoes. Looks like a bit of a volcanic uptick, including White Island volcano north of New Zealand on the list. Let's go down the list here at volcanodiscovery.com's Volcanoes Today page. La Palma still producing an 8,000-foot plume of volcanic ash through explosive activity. Karimsky exploding as well, 13,000-foot ash plume over Kamchatka from Karimsky. Suwanosejima, 5,000-foot ash plume over the Ryukyu Islands. Kadivar remains on the list here, exploding. 5,000-foot ash plume from Kadivar. Mount Ibu, 7,000-foot ash plume as it explodes. That's located on the Isle of Halmahera, Indonesia. Gas measurements confirmed an elevation of volcanic gases. Gas measurements confirmed an elevation of volcanic gases since 14 October at the White Island volcano in New Zealand. Also, carbon dioxide emissions have about quadrupled. Hydrogen sulfide levels have over tripled. Summit temperature was measured. Temperatures up at the summit measured to be 500 to 600 degrees Celsius. And the crater lake is higher than in late October due to torrential rainfall. So that could lead to a powerful steam-powered phreatic eruption. Fuego, occasional activity there at Fuego in Guatemala. Nevado del Ruiz producing a 19,000-foot ash plume as it explodes over Colombia. Sangay also exploding, 24,000-foot plume over Ecuador. Ashes have reached 16,000 feet of altitude over Revenador as it explodes in the country of Ecuador as well. Sabancaya exploding, 25,000-foot ash plume over Peru. And we're unable to detect if Nevados de Chilean is erupting or not. Please don't pole vault the caldera. Please do visit our links. And why wait? That's the promo code, by the way. Enter the promo code WHYWAIT on checkout. Store-wide at the Redbubble shop to get 20 to 60% off of your holiday gifts. Check it out. Our top seller is the Vaccinate This product. Let us know who you think your vaccination status's business is. Let us know in the comments. Thanks to everybody who's picked up merch. If you'd like the videos to continue to exist, consider supporting the channel via some merch. Again, they make great gifts. Why wait is the promo code to enter to save 20 to 60% on hundreds of different items with at least 13 different designs. We've sorted them by best selling, so check that out. Great gifts there. Great gifts at the smAsho merch shop. And you can find the link to that right at the homepage. smAshomash.com has a link right there to smAsho merch, as well as to the forum, as well as to the Smash team. Let's take a look at some magnetic data. And we decided to display the GOES magnetometer here over the GOES magnetometers, I should say, over the past 7 days, because we saw some very high readings early, right around midnight. That's midnight universal time on November 6th. We saw it get over 200 nanotesla there. More recently, we're seeing weak readings. And I'm still convinced that there is a coronal hole wind stream on the way, but hey, so far I have been incorrect. A rare incorrect coronal hole wind stream forecast from the channel. Let's take a look at the heliospheric current sheet and its polarity. And Earth is pretty solidly here in a South Pole current sheet. There you can see the latest image. North Pole current sheet over there to the west, out by stereo B, which is located right here. That's Lagrange point 4, the location of stereo B. Here's the line of sight view of the same data. This one also shows the solar magnetogram. You can see Sunspot 2895 right up here. That's the one to watch. It's got capable fields. Here's a line of sight coronal hole plot, and we've got more North Pole coronal holes and South Pole coronal holes rotating in from the east. This southern one looks like it's building and stalling a little bit on its rotation. And what you're seeing here is the solar polar field reversal cycle in effect. For example, you can actually see the sun's north polar field slowly making its way down to become the south polar field, and vice versa. The solar polar field reversal process, which is the underlying physics to the sunspot cycles. Here's coronal holes as viewed from the SDO. This is the 193 angstroms ionized iron wavelength. That well-defined one in the southern hemisphere is a South Pole-oriented coronal hole. Next, we'll show you detected sunspot groups. Actually, we're going to show you coronal mass ejection. It's pretty minor. It's not anticipated to strike the Earth. It's off to the west. So here's the view from Lagrange point 5 and Lagrange point 1, the location of stereo A and the LASCO SOHO C3. So you're going to see a little bit of a coronal mass ejection here. It's almost headed due west Nothing like an Earth-facing coronal mass ejection. Just sort of in the earthly vicinity. And we're keeping our coronal mass ejection watch in effect. We've lowered the warning to a watch at this point. So for you new viewers out there, we only forecast coronal mass ejections on this side of the sun, not on the far side. Earth would be over here from the perspective of stereo A. Let's go back to the Lagrangian points diagram again. Stereo A located at Lagrange 5. The Soho-Lascaux C3 located there at Lagrangian point 1. So a little CME there. We're still expecting to see more, though, especially on the far side. So that expect to see this filament out here, not be out there in the near future. Here's your flaring monitor over the past 3 days, the GOES 16 and GOES 17, monitoring X-rays. No major flares over the past about 24 hours. No strikes in the proton flux, no CMEs, no relativistic particles at the moment having struck Earth. We'll do the real-time solar wind next. And the current conditions on the solar wind are only about 3.4 protons per cubic centimeter. Solar wind speed only 350 kilometers per second. So we've got a slow and diffuse coronal hole wind, We've got a slow diffuse solar wind speed. Yes, that's what we call it, the solar wind. Solar wind weak and diffuse at the moment. KP index currently at 1 for you new viewers. That's a measure of global geomagnetism. We talked earlier in the video about another place to look at it. At the Potsdam. The Potsdam KP index. Anyway, continuing on. Here are your geospace magnetosphere movies looking at magnetohydrodynamic pressure over the past 4 hours. And this is one of the many data sets that we show daily, as we prefer for our viewers to understand the way that different data correlates. So in this case here, most of the magnetohydrodynamic pressure is on the magnetotail side of the planet, which would be to your right. The sun would be off to your left in this model view. And you're looking at two different 90-degree angle views here. The equatorial plane as if you're viewing Earth from above on the left, and the meridional plane as if you're viewing Earth from the side on the ecliptic plane on the right. Pretty homogeneous pressure here. A small increase toward the end of the geospace magnetosphere movie. Here, ground magnetic perturbations. Now you're looking at geospace delta B, Earth's magnetic field here at the ground level. And since there's a polar excursion going on, and since people are unnecessarily frightened of it, we show the data daily. So we've got some equatorial magnetic pulses here on the eastern portion of the planet there, from Africa all the way to Oceania. Here's a solar system diagram. By the way, did you see our cosmology segment yesterday? We put out a separate video. You can find all of our playlists at youtube.com/smashomash/playlists. Anyway, here's a solar system now. There's a solar system in 1 week. Mercury swinging past Mars on its way to lap Venus once again on the 16th, making its way around the backside of the sun. Next, solar flare monitor here and detected sunspot groups. Again, sunspot 2895 is beta gamma class. It's more than capable of producing major flares. So we've got a solar flare warning and a coronal mass ejection watch. Next, here's a star chart. And we've got some stuff rising ahead of the sun once again. I believe it's Mars and Mercury. I think that's Mars and Mercury, very close to each other there, near the ecliptic plane. And indeed, it is Mercury. And our cosmology segment today is going to be very brief. Check out the astronomy picture of the day. It's a bunch of fake images. Yeah, fake images, folks. You think those are real galaxies and stars and stuff? Well, think again. Those are fake. I'll give you a little tour here, a little nickel tour of the fake images. And these images are created in order to teach artificial intelligence algorithms how to pick out and then measure stars, and so on. So these are fake images just set up to train AI algorithms. Only one of these images is real, and I've got ideas as to which one. But that's the astronomy picture of the day. I'll scroll down so you can pause the video if you like to read the caption. We're going to continue on. Today's random object isn't random at all. It's Cygnus X3, which is the brightest intrinsic object visible from our solar system. Yeah, the brightest intrinsic object, folks. It's the epitome of eclipsing binaries, the only known cosmic ray point source that I'm aware of. Cygnus X3, it's the compact ultra-high mass object orbiting a Wolf-Rayet star. Let's take a look at it visually real quick here by clicking on Simbad and going to the CDS portal. And I didn't pick out anything in particular to show you here, but here is the XMM Newton, the red-green-blue composition in X-ray frequency. There's Cygnus X3. Some people believe the object to be a quark star, and the ancients believed it to be the source of all life on Earth and the place to where all souls return upon death. And I'll just show this in infrared as well. Cygnus X3. If you're in the northern hemisphere, you've likely had protons go through your brain from this distant star, the most luminous object visible from our solar system, known as Deneb. And yeah, Cygnus X3 is entry number 948 at the Neil Gehrels Swift Bat X-ray Observatory. And there it is in infrared on the 2MASS. And that's today's Cosmology segment. If you want to read more about Cygnus X3, check out our forum at smashomash.com/forum. No charging hazards going around planet Earth right now. Satellites are looking pretty chill. Here's the one-year chart of the relativistic electrons as reported by Solon.info. And SMASH team members would already be aware, if they check the website, that we have just recently gone back into warning territory, at least as the GOES 16 measures. A little bit of an electron warning here. And let's check the forecast. It's for a downtick. Again, I still say there's a coronal hole wind stream out there. We'll be watching the solar wind to see what happens. Next, the diagram of the atmosphere. We're just showing the total electron content forecast here, and we're seeing some chaos once again. Some surprising GPS errors are likely over places like North America and Canada. I'll let it play through a second time as we've got some irregularities there for all of you electron flux enthusiasts. So some errors happening there, not super high levels of electron flux, just a little bit of disorganization in the location of the total electron content. Next, we're going to show you the ionosphere. We're showing you this to show you where it is. It's at about 300 kilometers of altitude for the F layer. And we're seeing anomalies in the ionosphere as well. Not really a big surprise there to people who understand the physics, I'd say. And to content creators who don't understand the physics but earn millions of dollars per year, you should probably listen to people who understand the physics and not try to gaslight them. You'll fail and look pathetically. Next, the anomalogram. So this is the anomalogram showing you anomaly in megahertz from the 30-day median. And you've got anomalies of both the high and low frequency variety. Low frequency shown in red, high frequency in blue. There's a band of anomaly going across the mid-Atlantic Ocean. Right about here, you'll see a low frequency anomaly rather suddenly happen. Right about there. Anyway, here's the latest image. That's 12:15 Universal Time. Pardon our lateness today. There's the ionogram, and there's the anomalygram for 12:15 Universal. And now it's time to chew bubblegum and do bonus features, and I'm all out of bubblegum. Looking at the El Teide Spain ground-based solar observatory here, Once again, the area to watch the most would be Sunspot 2895. It's complex enough to have created a solar flare warning for the channel. There's the latest magnetogram. There's the latest intensitygram. Again, these umbrae have been splitting apart, and we're getting additional dark spots forming around the main umbrae there. So that is another sign that it is in a state of flux. We've also got a new sunspot, by the way, has formed over here. There's a new beta class group over there. There are the fields. And here's the NASA GOES 16 SUVI. This is what we usually stream when we're doing live Twitch streams of the sun. And check out the prominence in the northwestern limb. We showed it earlier. Here's the current data on it the last couple of hours. Here's 1700 angstroms. That's about 24 hours from when the video was recorded. I'll let it play through a second time there. So we've actually got 4 numbered sunspot groups now, assuming the one in the northwest stays intact. Here's your close-up. Beta Gamma class sunspot 2895. Quite well defined are the main umbrae there. And we'll close out the video today with 171 angstroms from the SDO. Thanks for tuning in. Congratulations on realizing the channel exists. And may that solar wind be at your back. Opinions expressed in this video and on the merch are not necessarily opinions of Smash News Network, least busted. Name it news.